Hello everyone, welcome back to my YouTube channel. Students, in this part 2 of number system, you are going to learn about irrational numbers and their representation on number line. So watch this video carefully. Students, you should know what are irrational numbers. So we can define numbers that cannot be represented as fraction, that is in the form of P over Q. All the numbers that cannot be represented in P upon Q or in fraction form, all those numbers are called irrational numbers. For example, square root of 2, square root of 3, value of pi. And watch these two examples also. In these two examples, you can see 0.10100, and so on. Means after every sequence, 10 is increased. Okay, here there is only 10 and next 2 zeros, then 3 zeros. So this sequence will be continuous infinitely. And similarly, in the next example, here 0.10, then double 10, triple 10, 4 times 1 and 0, and so on. Means this sequence will be continue. The next will be 5 times 1 and 0. The next is, so here we can see this pattern will follow continuously, infinitely. So these are called irrational numbers, and we cannot define these irrational numbers in fraction form. That's why they are called irrational numbers. So these are some examples. You can write more examples like this. Okay, students. Now, collection of rational and irrational numbers. You know what are rational numbers? That can be represented in form of P over Q. Okay, these are called rational numbers, and that cannot be represented as P over Q. These are called irrational numbers. So rational and irrational numbers, the collection of rational and irrational numbers is called real numbers. Okay, and every real number is represented by a unique point of the number line. It means we can represent an irrational number also, like these numbers can be represented on number line. So watch the next point, representation of irrational numbers on the number line. Students, here this section is very important for you, so watch carefully. How can you represent irrational numbers on number line? So we will start with a question, and question is locate square root of 2 on the number line. So we are going to locate or represent square root of 2 on number line. So in solution, there are some steps. First of all, you have to draw a number line, because we want to locate square root of 2 on number line. So we must draw a number line. Okay, and the next step, the first step will be assume a line AB of 1 unit on number line. Here on this number line, this is AB. This line segment is AB of 1 unit, because it starts from 0 to 1. So this is 1. Okay, so its unit is 1. And the next step, it B, draw a perpendicular BC of 1 unit. So here on the point B, we are going to draw a perpendicular. You know what is perpendicular? Perpendicular line is a vertical line that form a 90-degree angle with its base. Okay, so with the help of protractor, you can draw a perpendicular, and now we are going to cut an arc of 1 unit to get a point C on this perpendicular. So here with the help of compass, you can measure 1 unit. Okay, and then cut an arc on this perpendicular. Here you will get point C. Okay, this is also of 1 unit. Okay, now we will join AC. Okay, here I have draw with sketch pen so that you can easily see this video. Okay. Now join CA with which represents square root of 2. Here AC will represent square root of 2. You know why? Because when we apply Pythagoras theorem on this right angle triangle A, B and C. A, B, C, this is a right angle triangle. Here B is 90-degree angle, the right angle. Okay. So according to this Pythagoras theorem, CA is equal to square root of 2. And after that, the next step, we draw an arc. Here we draw an arc that will arc of AC. Here we have to take an arc radius of CA which intersect number line at square root. Okay, so here we take this arc and put this arc on the number line. Here we will get square root of 2. Okay students, so in this way we can represent square root of 2 on number line. The length distance of this is 0 to square root of 2. This point, this is equal to square root of 2. So students, I hope you have understood how can draw irrational number on number line. Okay, and watch next example. In this example, the next question is locate square root of 3 on number line. Similarly, we will get firstly we will get square root on number line. So we will start from the very first, from the number line. Draw a number line like this. Mark the numbers, integers on the number line, and then assume a line AB of 1 unit on this number line. Okay, this is AB. This is similar whatever we have done in square root of 2. Okay, this is 1 unit, and then we will draw a perpendicular at B. Here at the point of B we are going to draw an perpendicular. Okay students, and after drawn this perpendicular, we will take, here we are going to measure 1 unit with the help of compass and then cut the arc on this perpendicular. Here you will get point C. Okay, and the next step, we are going to join CA. Now join point C with A. Here it represents square root of 2. It is similar, which is whatever we have done in question 1. Okay, so after that, when we got square root, that is AC, here we assume CA as base. Here this is a base, and we are going to again draw a perpendicular. Okay, on the point of C. And this perpendicular, at this perpendicular we cut an arc of 1 unit. So we cut an arc here and of 1 unit, and we will get point D here. Okay, and what we'll do after that? Definitely, yes, we will join DA in the next step. Now join DA here. This is DA. Okay, with the help of ruler you can join AD or DA. It represents square root of 3. You know why it represents square root of 3? According to Pythagoras theorem, in right angle triangle ACD, we are talking about this right angle triangle, and then take an arc of AD. Here we will take an arc of AD, and we just cut this arc on number line like this. Here this point represents square root of 3 because this length is square root of 3, and we take this radius and cut this arc. So this point is also represent square root of 3. So this distance is also square root of 3. Okay students, and here DA it is equal to square root of, here this is base. Okay, this is base, just square the base and plus its perpendicular, that is 1, and then add both the number, we will get square root of 3. So students, I hope you can understand how can we draw square root of 3 on number line. Now exercise 1.2 and its first question is, state whether the following statements are true or false. Justify your answers. We have to justify and we have to put some reason why it is false or true. The first question, first statement is, every irrational number is a real number. Yes, every irrational number is a real number. This statement is true because real numbers are collection of rational and irrational numbers. So every rational number is a real number and every irrational number is also a real number. Next statement is, every point on the number line is of the form square root of m, where m is a natural number. So this statement is false because square root of m have the value of square root of m. This may have two types of value, that is positive and negative, but natural numbers cannot be negative. So this statement is false. Okay. And third statement is, every real number is an irrational number. So this statement is also false because every real number cannot be irrational. It may be rational also because real numbers are collection of rational and irrational numbers. Second question is, are the square roots of all the positive integers irrational? If not, give an example of the square root of a number that is a rational number. So students, square root of all positive numbers are not irrational. It may be rational. So we can say no, the square roots of all positive integers are not irrational. It may be rational. There are some examples like this. Square root of 4. The value of square root of 4 is 2 and square root of 9 is 3. Here 2 and 3 are rational numbers. These are not irrational. So we can say no, the square roots of all positive integers are not irrational. They may be rational also. Okay students, now watch the last question of this exercise. Question 3rd, show how square root of 5 can be represented on the number line. So again, this is a question of number line. So first, draw a number line and mark the integers on number line like this. Okay students, and in the case of square root of 5, step 1, assume a line AB of 2 units on a number line. Here in the case of square root of 5, when we are going to show square root of 5 number line, we have to take a line segment AB of 2 units. Here AB, it is of 2 units, 0 and this is 2. The unit of this line segment AB is 2. Now draw a perpendicular 8B. Here using this protractor we are going to draw a perpendicular, and after that we will cut a line segment BC of 1 unit. So we are measuring 1 unit and then cut this arc on this perpendicular and we will get here point C. Okay students, now join AC in next step, the step 3rd. Now join CA, which represent square root of 5. Why this CA represent square root of 5? The base is 2, its unit is 2 and perpendicular is 1. And when we apply Pythagoras theorem, okay, in this right angle triangle ABC, here CA equal to 2 square, base square plus perpendicular square, and after solving we will get square root of 5. Now we are taking this radius AC and draw an arc on this number line. Here it will cut and we will get the point square root of 5. This point shows square root of 5. So students, in this video you have learned how to draw number line and how to represent irrational numbers like square root of 2, 3, 5 and so on. You can easily represent them on this number line. So students, I hope you have enjoyed this video, and if you like this video, then comment me how much you have liked this. And if you have not subscribed this channel yet, please subscribe and tell your friends about this channel. You will got a lot of fun and knowledge in this video, in these videos, and definitely in this YouTube channel. Okay students, meet again next video. Till then, keep watching Radhyan's Tutorial Hub.